is wel beter voor je. Are we exploring every path forward? Or are we all driving in the same direction? We're living in a world that needs to change. Fast. Emissions are rising. Systems are under pressure. Even though the world is moving towards cleaner solutions, the questions remain. Let us introduce you to HyDriven, a student team based in Enschede. We are driven by the belief that innovation goes beyond, because real progress is never made by following the crowd. Each year, HyDriven works towards a goal: the designing and building of a hydrogen race car, working towards a future with zero emissions. But what we do goes beyond technology. Everything is in our hands, from idea to execution. We learn, we build, and we grow together. We are the faces behind the name, a team of young professionals. We are driven by curiosity and the need to look further. We do this because we believe in the potential. But we haven't got all the answers. That's why we need trust. Trust we have gained from our partners. They believe. Do you? What we do at HyDriven goes beyond ourselves. We present the possibilities today and for the future, because true innovation knows no limits. We are innovators. We are engineers. We are students. We are HyDriven. We believe in the potential. Do you?
Welcome partners, supporters and fellow racers. It is amazing to see that so many of you have joined us for this special occasion, the HyDriven car reveal of 2026. My name is Annemieke and I'm this year's technical manager.
And my name is Ime, and I'm one of the vehicle dynamics engineers. What if one element could change the way the world moves? 5 years ago, it started with an ambitious idea: proving the potential of hydrogen in the energy transition towards a world with zero emissions. We traded our victories in the Shell Eco Marathon for a completely new challenge: Formula Student, the world's largest student engineering competition. Here, we show what hydrogen can do and inspire other students to explore this new technology. Together with the competition, we help shape the hydrogen regulations, and in doing so, pave the way for other teams to follow. When we started, we stood alone. But now, our hard work is paying off. Last year, we already competed against one other team. This year, there will be 5 hydrogen-powered cars on the grid. But now that we have created our own competition, we can no longer just claim to have the fastest hydrogen car on track. We actually have to prove it this time. So, how can we beat those other teams?
Well, by scoring more points than our competitors. Within Formula Student, our work is evaluated both on and off the track. Off the track, we defend our engineering design, our manufacturing process, and we pitch a business idea. But on the track is where the real challenge begins. How fast can we accelerate? What speed do we carry through our corners? And ultimately, who sets the fastest lap times? This year, we will be setting those lap times at the circuit in Meppe, the Transpolis circuit in Lyon, and the place most of you will probably recognize from TV, the Red Bull Ring in Austria. At the beginning of the year, we set ourselves goals to improve the overall competitiveness of our car. We presented those goals to our partners at the Next Lab event. These goals rest on 3 key pillars: reliability, performance, and weight saving of at least 40 kilograms. We were a bit hesitant to promise this at this time, since 40 kilograms is quite a lot, and we still actually had to start making the car. Throughout the presentation, we'll show you what our innovations did to contribute towards these goals, and we can see if our promises held up.
Well, proving hydrogen works is one thing. Making sure the world knows it, that's the other half of our mission. It's why we actively go beyond the competition itself. We attend events like the Hannover Messe, one of the largest technology fairs in the world. Here, we show our concept to the industry. If we can make hydrogen work in the extreme condition of motorsports, just imagine what large companies can do with it. And we go to high schools, where we aim to inspire the younger generations and introduce them to the hydrogen technology in an engaging and accessible way. We share not only the technical aspects, but the broader impact hydrogen can make on the energy transition. This way, we hope to spark curiosity and motivate future engineers to join us in shaping a cleaner world.
With all these ambitious ideas, it's easy to forget that in the end, we are just a bunch of students. And that building a car does not always go as planned.
Well then, how do we manage to reach all these ambitions?
Well, the answer is simpler than you might think. It lies in how we work as a team. We are not just colleagues. Throughout the year, we became close friends. We learned about each other's strengths and weaknesses, and how to put up the best with one another. This did not come naturally. We put a lot of effort in this team's dynamic. We kick-started our year with a team weekend in early September. From that moment, we already knew who snores, who purely survives on coffee, and who should definitely not be trusted with a Bluetooth connection. Throughout the year, we built upon that with different team activities, from a rugby clinic to celebrating Christmas together. And my personal favorite, the pajama day at the office. It is moments like these that really brought us together as a team. Because when the pressure builds and deadlines close in, trust and friendship is what keeps you going. That is what allows you to work long days.
And sometimes nights. But it was this dedication of our team and those before us that allowed us to finish the car not 1, not 2, but 3 months earlier than ever before. This makes us the first HyDriven team to present a driving car at the reveal. So, let's talk about this car.
Power. Controlled to the millisecond. Hydrogen, electricity, data. Hundreds of systems. One purpose. Engineered to perform. This is hydroelectric.
Hello everyone, my name is Wessel and I'm the Chief Hydroelectric.
And I'm Peter, one of the hydrogen system engineers. And Wessel and I will walk you through this year's main improvements made by the hydroelectric department of the team. But before we get into what we improved this year, Wessel, how does the system actually work?
Well, in a nutshell, you can think of the hydrogen system as a small power plant inside the car. On the hydrogen side, we take hydrogen from our pressurized tank and regulate this to the right conditions for our fuel cell. In the meantime, we take air from our surroundings. This air is filtered and prepared before also being supplied to the fuel cell.
Now that the hydrogen and oxygen are suitable for usage in the fuel cell, it can start generating electricity. This electricity first gets converted to the right voltage, after which it gets stored in the battery or sent directly to the motor controller. This motor controller distributes the energy and, as the name suggests, controls the motors in order to drive the car.
Now, controlling the hydrogen system manually, it would be like running around your house, turning your heating on and off every few seconds on multiple floors, just to keep your house at the right temperature. As you can imagine, slightly impractical, to say the least. Luckily for you, in your house, you have a thermostat taking care of this. In our car, we have our own version of a thermostat, the fuel cell control unit. Similar to how a thermostat regulates the temperature in your house, the fuel cell control unit constantly receives information from sensors spread throughout the car and uses this information to decide exactly how the hydrogen system should operate to ensure optimal performance.
But this is not the only device monitoring our hydrogen system. To improve the reliability of the system, we introduced the hydrogen safety circuit. This circuit board is specifically designed to monitor our hydrogen tank and low pressure system. It operates independently and continuously checks whether all values stay within their expected range. If needed, it can safely shut down the hydrogen system, allowing us to operate closer to optimal performance limits with confidence. While improving the reliability and safety of our hydrogen system, we also continuously check for opportunities to reduce the overall system weight. By redesigning multiple components, we were able to reduce the overall system weight by a total of 15 kilograms. Now, reducing the weight is great, of course, but the lighting car also allowed us to push the performance of the car even further.
One of the biggest improvements this year was in the way we operate the fuel cell. Previously, the system operated more in a constant way, meaning that it always had a fixed power output. Now, we have developed a dynamic control system. This means that the power output of the fuel cell can adapt in real time to what the car requires. So, if the car accelerates, it responds by delivering more power. And if less power is needed, it scales back. The results of this new operating strategy were immediately visible. In fact, during testing, we were able to almost double the maximum power output of last year, reaching an all-time high of 30 kilowatts produced by our fuel cell.
Well, to put that number into perspective, it's approximately equivalent to fast charging 1,200 phones at the same time. So, from now on, you can reach each member of HyDriven on 40 different telephone numbers.
Of course, handling this increased power output reliably is just as important as generating it. So, let's take a closer look at how we do that.
The generated power first gets stored in the battery, which acts as an energy buffer. When the car requires more power than the fuel cell can deliver at the moment, the battery steps in and supplies the extra energy. After the battery, the motor controller takes over. Its job isn't just passing on power, it decides exactly how the motors should respond. This year, new motor controllers were introduced, which were lighter, more reliable and more compact, giving us better performance with less weight.
So far, we've mainly talked about individual components. But in the end, a race car is much more than just individual components. All the systems in the car need to work together as one. That is why communication throughout the car is extremely important. We connect all electrical systems in our car together with our wire.
Can become an issue. It's a bit like having too many conversations happening at once. Signals can start to disturb each other. That's why this year we completely redesigned the wire harness and improved how signals are managed throughout the car by introducing a new concept called input-output nodes, or ions for short.
These ions act as small communication hubs spread throughout the car. Instead of every component needing long individual wires, they first communicate with their local ion. These ions then communicate with each other via one central data wire, which you can see as a kind of information highway running through the car. So, instead of having lots of separate small roads crossing everywhere, information can now travel through a much cleaner and more organized structure. This reduced wiring complexity significantly, improved reliability, and even saved a little bit of weight.
So far, we've talked about the hydrogen, the oxygen, and the electricity flows within the car. But there's one more type of flow we haven't discussed yet: water. Unlike traditional engines, our system produces water as a byproduct. This means that instead of having harmful emissions, we have plain water as our output.
Water also plays a crucial role within the system itself. It is used in our cooling loops to regulate the temperature of, for example, the fuel cell. Keeping the fuel cell at its optimal temperature is extremely important for its performance. This year, within the cooling department, our main focus was on tuning the flow of the cooling system. We developed a new control strategy that ensures that the fuel cell reaches its optimal temperature as quickly as possible, and during operation stays at this temperature. Furthermore, we made several smaller improvements to ensure smooth and stable operation of our cooling systems.
Besides the improvements made in the control of the cooling flow, we made a switch to new customized radiators. These new radiators are a better fit for our application and demands, improving the overall performance of the cooling system. Simultaneously, they reduce the overall system weight by 6 kilograms.
And while all these improvements may seem small individually, together they had a huge impact on the overall reliability of our car. So what did all these improvements actually lead to?
Well, let us show you. The first ever HyDriven car driving before the car refuel, and not just before, a full month ahead. Within the hydroelectric department, we have done everything we can to reduce the weight while improving the performance, reliability, and safety of the system. However, there's only so much that we can show you. So now we will give the floor to Sjoerd and Thijs, who will tell you more about the mechanical improvements made this year.
Performance begins with precision. Every gram, every millimeter, every corner, designed to push beyond the limit. This is mechanics.
Hi, my name is Sjoerd and I'm a vehicle dynamics and drivetrain engineer.
And I'm Thijs, Chief Mechanics. Wessel and Peter just showed you the main improvements that made our hydrogen system more reliable. And now we will take you through how we build a race car with these components. For this, the mechanics team had two main objectives. That the performance of the car should increase, making it faster through corners, and we want to save as much weight as possible, since a lighter car is a faster car.
Let's start with our so-called chassis. It's the steel tubular frame which serves as the backbone of our car. This year we have switched to a new high-strength steel, which allowed us to use fewer and thinner tubes while still having a stronger chassis than ever. We have changed the whole front of our chassis, not only to make it lighter, but also to accommodate a more aerodynamic nose design. Additionally, we have lowered some of our hydrogen components, which lowered the center of mass and allowed us to remove the rear roll hoop, which saves us even more weight.
Lowering the components in the car might sound quite easy, but in fact you can think of it as building a Lego set in a very small space. Every component has a different shape, size, some are already maybe in place, and to make it easier for us, we have to connect everything using electrical and hydrogen wiring in between. Doing this becomes quite a puzzle. To make that puzzle even more complex, we have to think about how we attach all of these components to the car. Because, of course, we cannot just duct tape the fuel cell to the chassis.
This is why we have to design brackets. The brackets are there to hold the components firmly in place, even in case of a crash. So they have to be strong. But as we're building a high-performance race car, we want every aspect of our car to be as light as possible, which is also the case for our brackets.
We've redesigned almost all of them to save as much weight as we can. For this, we've thought very hard about which brackets are actually necessary and which ones we could reduce in weight and size through clever engineering solutions. So, we've made a lot of changes to our chassis and to our brackets. But what effect did this have in terms of weight saving?
With all of the changes made to our chassis and brackets, we have saved, in total, 70 kilos! All right, so we hit our weight-saving goal of 40 kilos. We're done, right?
Well, no, actually. We took on some other projects as well to further increase the performance of our new car.
As for building a race car, it needs to be fast. That means that it needs to be good at accelerating, braking, and of course cornering. This is where our suspension system comes in. But what exactly is a suspension system?
Well, the suspension system absorbs shocks from the track, keeping the wheels firmly on the ground. This gives us maximum grip from the tires. This allows the driver to steer the car as fast around corners as possible. Going around corners, however, in a Formula Student car is not as easy as your normal everyday car. Your normal everyday car has electric steering assistance, making steering lighter for you. However, this is not allowed in our competition, so all of the force needed to steer the car has to come from the driver. Since the speed of our car is increasing rapidly, it became heavier and heavier for the drivers to steer the car during the full 22 kilometers of endurance.
Driving at these speeds was not only hard on our drivers, it was also hard on our car. During our test days, we intended to push it to its absolute limits. And maybe sometimes a little bit over. You don't have to be a car expert to see that this is not how a wheel hub should look like.
So, with these experiences in mind, the vehicle dynamics team set out with two main objectives. We wanted to make steering lighter, and with this, increase our cornering speed.
To achieve these goals, we redesigned the whole front suspension package, changing almost every component. This resulted not only in a stronger and lighter front suspension, but also in us being able to tune the setup of our car more and achieve a higher steering angle. With a higher steering angle, we can turn even tighter into the corners, resulting in us going even faster on the tight and twisty tracks of a Formula Student event.
Next to changing the front suspension package, we've also redesigned the steering system. After lots of consideration, we decided to completely overhaul the current design and implement our first ever steering gearbox. This is a complicated design, but it gave us much more freedom to design the front suspension and how the driver is seated in the car.
With the implementation of the steering gearbox and the redesign of the front suspension, we've been able to move the steering wheel further away from the driver, which resulted in a lower, more natural position for our driver, similar to a Formula 1 car, which in turn made it easier to steer the car.
Next, with the changes made to the front suspension and to the steering system, we've been able to reduce the force needed to steer the car by 30%, and with this, we increased our cornering speed by 20%.
Having improved the handling of our car is nice, but as we get faster and faster, the aerodynamics of our car are becoming increasingly important. For this, we utilize downforce to keep it stable on track. But what exactly is downforce?
Well, just as airplane wings generate a force that lifts the plane off the ground, our car's wings generate a similar force, but upside down, pushing the car firmly on the track. This gives us more grip in high-speed corners. This year, the aerodynamics team has redesigned the nose of the car, the duct that brings cool air to the radiators, and the rear wing. We started off by simulating everything using advanced CFD software, which means we sort of place it in a digital wind tunnel, so that we can exactly know the impact of our changes. After this was done, the aerodynamics team designed everything from carbon fiber. We did this mostly in our own workshop, but we've also had great help from our partners in this.
So, let's see what these improvements have done to our aerodynamic performance. We have reduced the overall weight of all our aerodynamic components by 30%, while increasing the downforce by 20%. These simulations are nice, but we also have to see if what we simulate is also what we get in real life. For this, we did wind tunnel testing. We put parts of our rear wing in the wind tunnel to see if we could actually measure the same downforce as in our simulations.
And to our great surprise, yeah, it was very similar. The measured amounts of downforce were within 5% of what we calculated using our CFD software. This gives us the confidence that what we are simulating using digital models is actually happening on track in the real world. So, to summarize, we've improved our aerodynamic performance, and with this, we increased our cornering speed. But, as some of you may know, increasing our aerodynamic performance also has a positive effect on straight line speed.
However, on the small tracks of Formula Student, top speed is not the main priority. Because if you're going 300 kilometers an hour, you've probably missed the corner. So maybe it's not entirely necessary, but we still wanted to see if we can build a very fast racing car. So have we improved our top speed this year?
Well, before we tell you, let's take a quick look at the past. Our first driving car was Apollo, which drove 55 kilometers an hour. Then came Nebula, which had the same top speed, but drove on hydrogen for the first time. Last year, we got Nova, which boosted our top speed to 92 kilometers an hour. Which brings us to our year. We are proud to announce to you that we have reached a new top speed of 105 kilometers an hour.
That was a lot of technical information, right? Lucky for you, that was all. To give you a short summary of the main improvements made this year and how all these improvements fit into one race car, I would like to welcome Annemieke back onto the stage.
We are incredibly proud of everyone. This car represents months of challenge, dedication, and teamwork. I can imagine you feel a bit overwhelmed by all the technical details. But don't you worry, I will summarize them for you. At the beginning of the presentation, we stated our 3 key pillars, which were reliability, performance, and weight saving. And we have truly delivered on all 3 of them. We improved our reliability by implementing a hydrogen safety circuit, input-output nodes, and a new wire harness. We boosted performance through improved aerodynamics, a new dynamic fuel cell system, and a new suspension. And lastly, weight saving. At the beginning of the year, we set ourselves a goal of 40 kilograms, which is almost 10% of the weight of last year's car. Weight saving in motorsports is quite hard, so we thought we set ourselves ambitious goals. Oh boy, what were we wrong. Throughout the presentation, we kept up with a counter, with what our innovations did to contribute towards these goals. And I'm very proud to present the final result to you. We saved a total of 110 kilograms. All of these innovations come together in the vehicle you're about to see. So let's keep you not waiting any longer. Here's the moment you've all been waiting for. is now standing right here. This is Mira, the car we quite literally put our blood, sweat, and tears into. And we are incredibly proud to finally present her to you. The past 8 months have been a true roller coaster, from moments of doubt to breakthroughs. We laughed, we struggled, we pushed ourselves. But in the end, we grew stronger as a team. And that is what makes this project so special. I am incredibly proud of every single person in this team and previous generations of HyDriven. It is because of your dedication, resilience, creativity, but most importantly, the enthusiasm you bring to our project every day, what made it possible to have Mira standing here right now. I would like to take a moment to thank every single one of you. Starting off with powertrain. And that is hydrogen systems, cooling systems, drivetrain, vehicle dynamics, structural, aero, our chiefs, the communication team, and lastly, the management team. And of course, to our partners. Thank you for your trust and support. Without you, this project would not have been possible. The same amount of gratitude goes to our friends and family. Thank you for your patience, encouragement, and believing in us. It is because of your support that we were able to fully dedicate ourselves to this project. Lastly, I would like to thank Studio Newland and the Wilminktheater for making this presentation possible. Now, let's celebrate what we have achieved together. I would like to invite you for a drink in the foyer. The bar is open for the coming hour. Come take a closer look at Mira and feel free to ask us any questions. We would love to share more with you. Because in the end, that is what innovation is all about. Turning ambitions into reality. Together. Thank you.
Lekker bezig. Ging super.